Let's learn about making maps in R.
Let's talk about how to map. This may go without saying, this may be obvious, especially if you've taken any of our GIS courses. But really what we're trying to do is group data together to cluster them in meaningful ways. So the data that we're looking at here, we have 6 states, and this data is about 10 years old, but it was the average number of years required to complete a 4-year degree. So Illinois was at 4.5 years, Indiana was right on target at 4 years, Kentucky was a year and a half longer than expected, Tennessee was about a year longer. And what we're trying to look for are common clusters of data that seem to fit together in a meaningful way. So if we look at Indiana with 4, and we look at Missouri at 4 and 4.2, those are awfully close together. And we can say that those are essentially, or at least for the purposes of our map, those are the same value. So we're going to color them in this same creamy yellow color. Okay, because those two seem to belong together. If we look then at the next group, we have these two that obviously belong together very well. Illinois had 4.5 and Ohio has 4.4. Those are close enough together that we're going to say those are the same situation, right? They have the same values. So Illinois and Ohio, we will color in the same pumpkin orange color here. When we look at the data that we have left here, we have Tennessee at 4.9 and Kentucky at 5.5. Our other clusters were a lot closer than that. These are 0.6 off, so I think these actually belong in 2 different groups. So I'm going to say Tennessee at 4.9. Whoops, excuse me there. Tennessee at 4.9, we're going to paint in kind of this papaya orange color. And it's on its own. There's no other state that takes about 4.9 years. And then we will go up to this richer orange for Kentucky. This is kind of the color of grapefruit. Anyway, we have created a map. So there are 2 considerations that we need to think about when we're creating a map. We have to find some way of clustering our data, and that makes a different map, right? If I had made Tennessee and Kentucky the same color, that would be a different map than what I'm showing here, right? I'm kind of highlighting the fact that it takes more in Kentucky and that they're kind of anomalous on their own, right? So the way that you cluster the data has meaning, or can affect the way the data are presented. And then the colors that you choose, I just happen to unintentionally pick the oranges of vegetables and fruits here, but some colors have meaning, right? Red means stop, means danger. Green means go. And so the colors that you pick also, invest meaning into the way that you create your map. Mapping in R can be a little bit more complicated. So let's take a look at how to do that. We're going to talk about 2 ways to map data. I'm going to open up the SPDEP package, that stands for Spatial Dependency Package, and I'm going to ask for an example of the Columbus data set. It will open that up for us. Okay, and now the Columbus data set, if I open that up, I think is an SF object. Let's ask, what is Columbus? SF. And I want to convert that to a spatial polygons data frame. So I'm going to call this COL, short for Columbus. That might be confusing later when I talk about colors. We'll call it Columbus. We'll call it Colum. That way there's a difference. And we're going to use the as command to convert Columbus to a spatial object. Okay. And inside Colum, let's plot that first and see what we're looking at here. So these are the outlines of neighborhoods in Columbus, Ohio. And we have several different variables associated with each one of those data sets, those polygons. We have their area, their perimeter. I don't know exactly what these are. This is the home value, the median income of people that live there, the crime rates, the amount of open space, how many houses have plumbing. This is obviously an old data set. I forgot what that stands for. This is distance to central business district. So there's a lot of data in there. We're going to look at the crime data. So we're going to call this crime, and we're going to pull from column the crime data set. Okay. Get a close up there so that you can see that. Now we want to try to map these data. The easiest way to do that is with the GIS tools package. So we will open up GIS tools, and we want to create a shades or a set of colors. So I'm going to call this the colors, and I'm going to set that equal to the result of auto shading, which is one of the functions inside this package. We want to auto shade crime. We want 7 different colors, and we want the colors COL to be based on Brewer Pal 7, and let's go with yellow to green to blue. Okay, so there was a geography professor named Brewer. When she was a graduate student, she did her research on colors and cartography. Her name was Brewer, and there is now a package in R called Color Brewer, and there's a function called Brewer Pal. And we're going to get these. You have to memorize these. If you want to take a look at those, look at the help menu for Brewer Pal. But this is a set of colors that goes from yellow through green to blue, and we want 7 of those colors. Okay, so this line will automatically set up our color scheme for us. And then when we plot these data, we're going to use the choropleth function, and we're going to map the column polygons, the crime data, and we're going to map them using the colors that we had created. So if we run all of these, that should produce a color choropleth map that ranges yellow through green through blue. Okay, so we've done that. Now this auto shading uses quantiles in order to assign membership to each of the polygons. That means that there are just as many light yellow polygons as there are dark blue polygons, right? So 1, 2, 3, 4, 5, 6, 7, 8. No matter what the original data look like, I'm going to have equal numbers of polygons painted in each color, whether that is the best representation for the data or not. So this is a very simple way to make a very pretty map, but it may not be the most accurate. My favorite way, if I have to manipulate the data a little bit, not manipulate the data, but manage the map, plan the map a little bit better, requires the package class int, and I'm going to create a set of intervals here using the class intervals command, and I'm going to zoom out here so I can see the help menu a little bit. The variable that I want to map is crime. I want 7 different colors, and I'll leave style at quantile. Then I'm going to create a palette. So maybe I should clarify what this is doing. So this is going to break this variable down into classes. It's going to break crime into 7 classes, and the default is quantile, so it's exactly what auto shading was doing up here. And I just want out of it the breaks. So if I run this, I can show you what that looks like. Int. So this just means that my first group, whatever color I end up making it, stretches from 0.178 to 17.513. My second group goes from 17.513 to 23.564, and these breaks are designed to break my data down into the same size membership in each color. Okay. So then I have to determine membership for each of these. So, well, I'm going to pick a color first. I'm going to say PAL, short for palette. And I'm going to say Brewer Pal. We want 7 classes again. So this number and this number have to be the same number. And let's use red to gray. In fact, let's reverse those with the reverse command, so that it's actually gray to red. Okay. Then we have to determine the colors using, I'm going to say take the 7 colors in my palette list and use find intervals using crime int and set that to true and make sure that I'm doing that right. I'll find interval is singular. Okay, so now what I have created here is a list of colors. There should be 49 different colors because I have 49 different polygons. And all I have to say then is plot the rhombus, C-O-L-U-M, and set the color equal to the colors. And it will give me this graph. So the reason I reversed it up here was so that the high crime areas were red instead of the low crime areas. If I had not done that, it would still look good. We would just have the grays and the red mixed, and red, you know, for whatever cultural reasons, seems to imply danger, and crime is danger. So there we go. Now the reason I like this system better is I can come up here under class intervals, and right now the default is style is set to quantiles. But if I don't want that, I don't have to. I can say there are all kinds of options. In fact, if you want to look at what all of the options are, you could come here to the help menu for class intervals. And it explains here under style that I can use fixed, standard deviation breaks, equal interval, pretty, which should never be used. And then we have a group of clustering algorithms, k-means clustering, H clustering, and B clustering. And then we also have Fisher and Jinx. So these are natural breaks methods, and these are the methods that ArcGIS uses when you ask for natural breaks. So you have to look at your data a little bit and decide what you want to use, but if you stick with quantile, like choropleth mapping does, it forces there to be the same number of polygons in each color. And if you have 5 colors that are very, very low and the 6th one is high, but you have to have 6 colors painted in the same color, that 6th one is going to get aggregated with the other ones, and it's going to look like they're very similar to each other, even if they're not. So let's take a look at, let's use Jinx here, style set to Jinx, and see what we get, see if it makes a different map. Let's pull up our map here. So here is the map based on equal interval, and here is the map based on Jinx. And so it is a little bit different, right? And you have to decide what you would like to do and what you're going to use, you know, to explore the data a little bit. Probably a good way to explore that data would be to plot a density plot. Excuse me. Density plot crime. Oh, we have a very normal distribution. So actually quantile is probably our best bet here. We can pick different colors too. I think, if I remember right, this is a color. Apparently not. Let's look up colors for Blue Pal. Yeah, see, all of these are options here. Let's do yellow, orange to, I think that's brown. Yellow, orange to brown. And we don't need to reverse that, do we? Let's get the dark colors for higher crime rates, just because that catches the eye a little bit better. There you go. So you have all kinds of ways you can manipulate this graph, this map, into showing the data the way you want it to be done. If your data are pretty straightforward, just use the choropleth tool inside the GIS tools. Since our data are normally distributed or fairly normally distributed, that probably would have been an excellent option here. But if you want a little bit more control of how your coloring and clustering is done, then use the class int functions.